Okay, welcome in. This is going to be our first video on regression, which is a very popular quantitative tool. You've probably seen it in a variety of contexts. It's pretty ubiquitous across all sorts of different fields and jobs. And I think most people are familiar with the output of regression, but less familiar with kind of how the underlying mechanisms work. And it's very useful to understand those mechanisms, and it's surprisingly easy to actually work through and see the math behind sort of what's happening with regression. Regression is a very simple machine learning technique, and I think machine learning is a very amorphous term. A lot of times people ask me, what does machine learning mean? And if you know regression, you know a bit of machine learning, and it opens the door for more complicated, more modern machine learning methods down the road. All said, I think understanding the background of regression, which we're going to do in this video, and then understanding the actual formulas, equations, and processes behind it, which we'll do in the next couple of videos, will be very valuable. So regression all starts with data. And that data is going to be x, y data. We can expand to have multiple x's, but in this video series, we're just going to think about having one x. And we can imagine our x is 2, 4, 5, 6, 7, 8, whatever. We have a bunch of x values, and then we have a bunch of y values, 3.1, 5.7, 4.8, 8.9, 2.3, man, 2.3 is a little, we'll do 12.3. And these could be anything, right? The x values could be, number of hours per week that you spend working out, and the y values could be, like calories burned in hundreds or something. Or I think, a classic example is like x is the number of crickets that you have, and y are the number of cricket sounds or beeps or whatever you hear per minute. But very general, we can have any x, any y. You can imagine in whatever field you're in, you have data where you have an x and a y. And the natural thing to do is plot it, right? And I'm not going to plot this data exactly, just a rough idea of data with a positive relationship, which we have here. And we have our x, and we have our y. I could do the 4 quadrants, full Cartesian coordinate here. We're just looking at the positive quadrant because we have kind of positive data. And the idea behind regression is we want to learn a relationship between the x and the y. We want to learn the relationship that is governing the data. And to do that, we are going to establish our line of best fit. So we are going to fit some model where we predict y, and we're going to put a little hat on y. We put a hat on y in statistics when we're predicting something. So our estimated y is going to be this alpha, which is our intercept, plus beta, our slope, times our x value. The nice thing about this model is, and I'm just going to write so we can remember, this is our line of best fit. The nice thing about this model is that once we've figured out what our line is, we can predict values for new data points. So if I added like an x, a x value of 9, or maybe I'm going to do a data point within the data set so I don't get weird extrapolation issues. If I have an x value of 3, I would plug x equals 3 into here. I'd have my numbers that I figured out for alpha and beta, and I'd get a predicted value of y. Maybe it's 6.2 or something. And that's what's really useful about regression, is we can learn the relationship and predict new things by using kind of this very simple equation. So the natural question is, how do we choose alpha and beta? And the visual, that's the mathematical kind of background. The visual idea is, how do we fit a line to kind of fit this data? I'm just going to draw kind of a line here. And I think everyone would agree, it's a little bit, I did draw a perfectly straight line, but it is linear. I think everyone would agree this is a pretty good fit of the data. It kind of goes through the middle of the points, which is intuitive. It matches it. Maybe I could have drawn it a little steeper, a little narrower. And this line has some, if I continued, it has some y-intercept, which is this alpha, and it also has some slope, which is this beta. Okay, and this would be our line of best fit. And a lot of natural questions arise, like why wouldn't I make this line a little bit less steep, maybe more steep? I'm kind of looking at it more, maybe more steep would be a better fit. And the question is, how do we choose alpha and beta, which are the only two parameters, either moving this line up or rotating it? How do we choose alpha and beta such that it is the best fit for our data? And again, we can kind of see visually what makes the best fit, but we're going to actually figure that out mathematically. So this is the setup, and in the next couple of videos, we're going to quantify how to choose alpha and beta. We're going to explain why it makes it the best fit, and we're going to go about actually finding alpha and beta as a function of our data x and y. So we'll see you in the next video.